Hello, everybody, and welcome to this online session about the AI machine, standardized deployment of algorithmic trading strategies. My name is Yves. I'm founder and managing partner of the Python Quants. I'm also founder and CEO of the AI machine, about which today's online session is about. I'm going to dive first into the slide deck that I have prepared here. And I will later on go, of course, into some live demos. But first, let me set the frame and the stage for what the AI machine is all about. So the group itself, we have a group of 3 companies. Most of you might be familiar with the Python Quants, where we provide trainings about Python for finance, in particular financial data science, computational finance, and one of our core topics there is algorithmic trading. Then the recently founded the AI machine. We also run financial capital management, FinCap for short, which is concerned with corporate advisory and also financial management. The Python Quants group, again, most of you might know it, is centered around open source topics, but in particular, of course, Python for quantitative finance, such as computational finance, mathematical finance, financial engineering, but more and more these days also, of course, about algorithmic trading. We provide services for financial institutions on a global basis. We provide trainings. We run the Quant platform with some 15,000 plus users. We've open sourced a financial analytics library, and I've written a couple of books. And we also run events, the next of which will be, for example, in London, our For Python Quants bootcamp. The AI machine is an ongoing project which we started a couple of months ago. It is about the standardized deployment of AI-based algorithmic trading strategies. The focus of a researcher, algorithmic trader, should be on research and trading to come up with strategies, and not that much about DevOps and deployment details. And this is what the AI machine is about. More about that, of course, later on. What the AI machine allows you to do is template-based strategy definition. We will see this in action. Standardized backtesting, also part of the demo, to run multiple strategies in parallel. We might run maybe 2, for example, in parallel. And the real-time visual monitoring and audit, as well as detailed reporting afterwards. So this is what today's session is about. It's, so to say, an update, status update with regard to our ongoing project, which we implement with an experienced team in India, Hyderabad. Founder myself, if you don't know it yet, you'll find all the information about myself, my talks, podcasts, videos, resources about Python for finance and algo trading under hillpish.com. So this is not a personal page, but this is rather a collection of all my public talks, again, podcasts, and many more resources about our core topics. The books that I've published, here in the middle you see, I think, the best-selling one of the 3, Python for Finance. I've just finished my draft for the 2nd edition. This will come out soon. So I hope that towards the end of 2018, the print edition will be there right in time for Christmas. The team itself, we have grown the team quite a bit. In Germany, where our origin is, it's where I'm located. We have an assistant there. We have one experienced software architect with some 15 years of experience. In the UK, we work with an FX quant analyst, trader. We also have software architects and people who are kind of pretty experienced with regard to infrastructure and UI, UX. In India. So altogether, we have quite a few people these days that are concerned with what we call finance. So where the AI is now in the middle of finance, and we think, and a little bit more on that in a minute, that data-driven and AI-first finance will reshape the financial industry and the complete finance landscape as we know it today. Some strategic partners, of course, are also important. So we work since quite a while with Thomson Reuters together with regard to the Icon Data API, for example, where we have access to wealth of information via a neat, modern, RESTful API with a a proper Python wrapper package, which makes it easy to retrieve not only structured historical data, for example, but also unstructured data such as news. And in the near future, streaming data, for example, for FX will also be available. We work since a while. You might have seen me giving webinars or talks about it with FXCM, trading platform focused on FX and CFDs together. And recently we started working with Dow Jones that have a fantastic offering, mostly on the unstructured data side, with DNA providing some 1 billion articles via the API to which you have access in a pretty structured and efficient way. So without partners, strong partners, we couldn't do what we do these days. A few words on data-driven finance. I'm pretty sure all of you have read Financial Times, Wall Street Journal. Even if it's rare, in particular for me, to read it in print form, of course you have access here to all the materials, to the content these days on the web, for example. But this is, I like to say, not what drives financial markets anymore. It's not that people sit down and have a look at the Financial Times early in the morning and then show up for work and say, well, I've read this in the Financial Times and I want to place a trade on XYZ because I gained this insight. I think times have changed there a little bit. People are mostly using, when they are in a trade or let's say risk capacity, when they work on the buy side end or on the sell side, using terminals. Here you see the HTML5 version of the Thomson Reuters icon terminal, where you have, of course, a streamlined access to all the data, for example, related to Apple or to any other traded instrument to this end. So you don't need to pick up any printed source anymore. But even that is not what in particular drives the equity markets anymore. The equity markets are driven by data that is accessible in programmatic form. And here is a recent article from the Financial Times itself, where you see that hedge funds, banks and venture capital firms are piling up their investments into data companies because it has become so important to have access to data beyond the standard sources that you have in the form of the printed newspapers or the terminals. So what is typically then subsumed under alternative data, where you find any kind of specialized data sets that might be useful, not only maybe for real-time trading, but for investment asset management or risk management or other purposes to this end. So you see here more and more companies that are on the investment side, like Two Sigma in New York, or an activist hedge fund, your third point. They invest kind of decent sums into such data providers because it has become more and more important since, as I said before, it's not human beings that drive most of the, at least, equity turnover these days anymore. It's kind of programs. And here you see the example from the Icon Data API, where you get via a simple method call once you're connected to the API, for example, tick data for Apple, and you retrieve, let's say, for 15 minutes on a certain trading day, some 2,000 tick data points for a single stock only. So this is nothing that people would like to print or human beings would like to read through. It's well too much. So this is a proper job that can be handled by machines, by computers, and we on the Python side, we are having a good time in general because most of the wrappers are available for Python. Like here, Icon, once it is imported again, you just have a few method calls and you're up and running with all the data. So the machine doesn't care whether it's 2,000 lines, 20,000, 200,000. Even on a local machine, it's today pretty easy and fast, in particular, to process such amounts of data. But the whole story doesn't end here. It goes further, and that some might say, well, yeah, of course, but I want to read the news. I want to understand what's going on in the world. But the machines read the news as well. So we have machine-readable news, and basically the minimum requirement is that it is in kind of a standard format. So, for example, via the Icon Data API, you get news delivered in HTML. This is one of the sample formats there. And of course, it's pretty simple and straightforward with natural language processing kits and other applications. Python world, we have some beautiful soup functionality there and many more that allow you to process such data sets that are then unstructured and text-based pretty efficiently. And you can then run your natural language processing and NLP algorithms on top of that, do some sentiment analysis. And for some simple applications, you get already results, reasonable results that you can work with after a few lines of code. Of course, once get more specialized, of course, the work is a little bit harder to accomplish, but nevertheless, the machine that reads 2 million lines of tick data does the same job with 2 million articles. So we human beings couldn't even think of reading through 2 million news articles that might be relevant for a certain question that we have asked, like an investment hypothesis, but the machine can do this for us. Of course, it can come up pretty quickly with the respective news. So this is what I call data-driven finance, which is kind of the prerequisite for what is then AI first finance. More on that in a minute. Here you see a small sample collection of stuff that we have in the Python ecosystem, which allows us to work efficiently with all the partly, we must say, newly or just recently available data sets. Of course, Python, we have tools like IPython, Jupyter, just to name two popular ones. There are many more these days. We have NumPy, Matplotlib, Pandas. If you want to stick to Excel, for example, for the graphical user interface capabilities, that's fantastic because you have Excel Wings where you can replace VBA and so to say the storage capacity, which is kind of limited within an Excel spreadsheet by the power of a Python-based analytical backend. So you have all the means available, and most of it is open source, and it's kind of standards readily available, and it's installed within minutes to get started with data-driven finance. And there are also, like mentioned before, one of our partners, FXCM, which provides, for example, tick data for quite a bunch of currency pairs, where you can get such data for free, and you can get started with open source, so free software and free data, open data, and get started with your analysis. Speaking of data-driven finance and mentioning that this is the prerequisite for AI-first finance, we know that in many areas when you want to apply the most recent machine learning, deep learning techniques, that indeed you need what is typically called big data. Sometimes it's just mid data, that's already enough, because in finance we generally don't deal really with what big data means for the big social networks, for example. It's typically not the petabytes, not even the terabytes per run, but in the gigabyte space you can easily run into, and we have the data available for these things. And here one of the recent publications about the topics called Advances in Financial Machine Learning. One of my favorite quotes is that econometrics might be good enough to succeed in academia for now, but succeeding in practice requires machine learning. So maybe it's a little bit too far-fetched, because all of these techniques have their place, have their applications, but I think we are about to enter a new area. This is what I mean when I talk about AI first finance, which might not be there yet, but I think this is something that we will see for sure on the horizon. And this is one of the first books that touches upon the specifics of financial machine learning. Contrary to some general machine learnings and algorithms, basically this book is agnostic with regard to the algorithms applied, but there are many specific things that you need to take into account when you work with, for example, financial time series data. But on the other hand, again, we have fantastic time here in algorithmic trading to get now a little bit more specific in that what is happening in other places, machine and deep learning, with regard to data availability, algorithms use the hardware that is getting more powerful and more dedicated and specialized, can be applied in our field as well. So we are benefiting more or less one-to-one in our field from what others come up with in a completely different field, like when people are trying to build a safe, securely navigating, self-driving car. They solve problems. They apply algorithms and techniques that might be pretty helpful when we want to do automation with regard to trading investments. So to build a AI-based algo trading machine. And of course, many processes and elements in the middle here are basically the same, no matter what your automation goal might be. Of course, there are many others there as well. But compared to a self-driving car, I like to say that we are having a little bit of an easier time because we don't need to build a physical thing that is navigating the real physical world. And when an algo doesn't do what it's supposed to do, we might lose some money. But a self-driving car, as we all know, can hurt people or can even represent a threat for the life of a single person or of group. So here we are dealing with financial risk, of course, but not with the physical world where we can harm living beings in this regard. Nevertheless, we can benefit tremendously from what is going on in other fields in this regard. So in that sense, we are now in an area where more and more traditional finance theory, which has been mainly brain-driven and maybe suffered from the beauty myth because many researchers were just looking for some nice equations built on some elegant assumptions, but that once tested here didn't prove too useful. So when the market processes the available data X and comes up with Y, we know that markets are nonlinear, complex, and changing, but the simple, elegant theories might not be rich enough, or they might be too simple, to put it the other way around, in order to explain what's going on. With the advent of machine learning algorithms on the financial scene, we have the big data now available and we can process it. We might now be able to apply models that are not that simple, not that elegant, not single line equations, but they nevertheless, when parameterized correctly, are able to explain more stuffs accurately enough, let's say, than the traditional theory. So here we would then enter the age of data-driven and AI-first finance. We have big data, we have the models and everything that needs to be in the background, the infrastructure, like the big working memory, the scalable infrastructure with regard to the compute nodes and so forth available, and we can train the models to come up with some valuable foresight predictions. And this is what the rest of the demo will be about. I said it before, all that requires, of course, not only different software. So with the standard software, like what we have in our Python ecosystem, like NumPy and Pandas, we can do quite a lot. We can process data pretty efficiently and conveniently, even for the non-hardcore developer. But for machine and deep learning, we need other packages. Is the first thing that we need, like scikit-learn, for example, or TensorFlow, to name two very popular ones. There are other like wrapper packages with a more nicely designed interface like Keras built on top of TensorFlow. Some other initiatives like Fast AI, which is built on PyTorch. So in the Python ecosystem, we have a lot to choose from. But I think these are two popular ones. And for example, the hardware side also needs to be considered. So once we enter the deep learning arena, we should think of using different hardware. And today, typically, the GPUs from NVIDIA are the tools of choice, or TPUs, specialized chips from Google, for example. But again, we have the issue that the hardware needs to be tailored once the workload gets big enough. But we can start it with like regular commodity hardware in the research phase, and maybe just for production scale applications, we need to really think then of better and faster hardware. So now, against this background, what does this all mean with regard to the research and development and deployment process for AI-based algorithmic trading strategies? So later on, when I dive into the demo, I will not only rely on highly sophisticated, let's say, black box model, one of the major critiques with regard to machine and deep learning techniques. I will also show pretty simple, straightforward strategies based on some technical indicators that have been around for, I would like to say, ages. So, for example, simple moving averages have been in use since many, many decades. They have been analyzed thoroughly also from the, let's say, serious academia side, and not only the practitioner chartist side. So there is lots of background, and we can use this as an example, but I will also have an example where we make heavy use of a machine learning based algorithm in this regard. But the algorithm, similar to what I said to the book by Marcos Lopez de Prado, is only of second order importance. The focus here should be on the process and the deployment side of things. But let me get started with an overview. So when we talk about algorithmic trading, and of course here, this is a simplified view which should make things a little bit more concrete. But basically, when I speak of the simplified view, we can think of algorithmic trading divided into 5 areas. We need to have some data to get started. Data in 2 forms, basically. So first, probably we need historical data to do some backtesting, some analysis, and later on we would need real-time data. But let's get started with historical data. So for example, here, with regard to the euro-US dollar exchange rate, we might want to work on 1-minute bars, and we go here, let's say, for August and September 2018, so to have a pretty recent time interval. And you might say, well, now let's create some features and labels based on this data. So this is what we would call raw data, and then we do some transformations, and we come up with features and labels for our machine and deep learning algorithms. This is actually what we think in terms of the algorithmic trading researcher or quant, where the core of the core for the research is. So data is available basically en masse, we can say, and at low cost these days. It's not about, like it has been like 1-2 decades ago in option pricing, let's say, that the research effort was directed towards coming up with new models. Today we have kind of the need to come up with new proper features and labels that we can feed the models with, that need to be trained. And here I stay on the generic side by saying, well, some time series features, and there are even libraries available that create time series features in a semi-automatic way, or automatic way even, like minimum maximum values overrolling means, overrolling windows, like sort of moving averages, like lagged returns data, and all these kind of time series features that can be created can in that sense also be created automatically. But maybe we can put in a little bit more effort here. Or economic indicators. If you want to do FX trading, who says that the economy doesn't have an influence? So we can use such data as well. And for labels, we might be interested in the directional movement of the exchange rate. So this is then, let's say, the second layer. Raw data, and here is the transformed data that we can then feed into the machine and deep learning models. I have picked here just two. They, of course, the menu of options is much wider. Support vector machine, DNN classifier. We would do the training and testing and the validation of the model so that we have, let's say, the technical algorithm available that can then be used to do vectorized and or event-based backtesting, and, for example, to visualize results. I will show you some short demos of all these steps later on. And once you say, well, this is fantastic, I've discovered the holy grail, I want to deploy this, you would then go on and would need to transform your algorithm to what is called an online algorithm. What we are talking about here is typically called an offline algorithm because you have the data available from the outset. Online algorithms are slightly different in that they are designed to digest data incrementally, step by step. So you get new data every second, every 10 seconds, or you get it in the form of tick data. But no matter what you get, you need to be able to process the data as it comes in and not kind of like dealing with a data set that is there and is not changed over time. You would deploy your algorithm in the cloud, and you would need to monitor and risk manage it. And with risk management, I'm not talking about only about, like, let's say, financial risk, but also what operational risk. You need to make sure that everything is running fine and that the internet connection is up and running, that you retrieve all the data that is required, and all these things, mostly in the area of technological and operational risk, need to be taken care of. So this is a simplified description of what we have. I'm skipping here a little bit over the post-trade analysis, although I will touch upon later on this topic as well. In our ecosystem, where we now have a look, we have basically everything available. So in order to accomplish these tasks, we have at our fingertips not everything that you see here is for free, but you can basically model this whole value chain or a whole tool chain over all the different steps for free based on open data alone and based on open source alone. The offerings by Thomson Reuters, by Dow Jones, for example, they are paid for subscription service and the cost can run pretty high. But if you're, for example, a trader, a customer of FXCM or of Wanda to this end, you get their data in general for free. So for a retail trader, this might be pretty attractive. Of course, the data set is limited to what they provide. Doesn't mirror, for example, what Thomson Reuters provides you with. But if you want to trade their instruments, then at least you get access to the historical data for all the instruments available there. To make just one example, you have the basic tools available to make all the transformations that are required. You have machine and deep learning available. Of course, for your NVIDIA hardware, you need to pay a little bit, though this usually doesn't come for free. Excel is licensed software, but you don't need Excel. I'm just a little bit driven by our corporate clients. They mostly use Excel for quite diverse purposes these days, but you can just resort to Jupyter, for example, using Matplotlib for visualization. And when we talk about deployment, you can deploy it, let's say, getting started with a $5 US or $10 per month droplet, which means cloud instance at DigitalOcean, and you can run your stuff in real time on FXCM or Wanda or some other brokers out there. So basically, we have everything available, and if you know what you do, if you're, for example, a seasoned data scientist, a hardcore Python programmer, and you say, now I want to get started with trading, then you may have mastered the tools already. You just need to connect here to the historical data APIs, and you need to write up your code in order to deploy it in the cloud. When I talk about this with a few sentences, this might be, of course, hard work, weeks or sometimes even months of hard work. So I don't want to simplify things here too much, but what I want to make here the point that everything is basically available, and it's not kind of that just the big institutional investors with their multi-million-dollar budgets and the hundreds of people in the back and front office functions are able to do that. Now, we as a single person, individual with a little bit of experience and education in the field, training in the field, we can accomplish what I'm talking about here. And when I speak of that, I want to make here a little example from a recent workshop that I've given 20th September in London. My workshop was about 90 minutes with some 100 people in attendance. And basically, within the 90 minutes, we went through all the three major pillars there. So we started with the platform, signing up for a demo account with FXCM. We installed the wrapper. We did some first steps with the API, retrieving historical data. Then we retrieved the data set based on which we generated the features and the labels. We trained classification models. We used a multi-layer perceptron model, so deep neural network model. We did some vectorized backtesting. We got started with streaming tick data. We collected the data as we went. We transformed the algorithm to an online algorithm. And towards the end of the 90 minutes, all with live coding, starting from scratch, we were doing some automated trading live, but on a local machine, not really scalable, no monitoring or risk management, but basically the fundamental steps can be accomplished within a relatively short period of time. And the message here is that the barriers of entry have become pretty low. But nevertheless, what we need to consider in this regard that you need to have the expertise in many different fields. You need to be able to work with the data. You need to know exactly what to do with regard to backtesting. You need to know exactly how to code it up and how to do deployment and monitoring. So here I'm showing a screenshot of HTOP running on one of my cloud instances. So it's quite a diverse field to be mastered. And the most involved and complex side, although this sometimes might look pretty simple, but from experience is all but simple, is the deployment side. So here towards the right end, it gets more and more involved, and it's kind of like this 80-20 feeling that you get. You think you got kind of like to 80% of your way of your endeavor, with 20% of the effort, and the last 20% then take up indeed the 80% of the effort, namely when you want to run your strategies in a robust and reliable way. And this is what this chart illustrates. So again, we have our 5 areas, and I think many people, for example, with our trainings, the certificate program in Python for algorithmic trading over like 12 weeks plus 4 weeks practice, are able to get through these 4 steps there. They say, well, I'm now skilled at research and interactive financial analytics, and this is what I can come up with. And the result of this phase, so to say, the first major phase, where I say, well, now I've got the milestone, I have my strategy, might be a few hundred lines of code. Let's say 500 or 700 lines of code that you come up with. And then there is the deployment gap, the last mile problem, because once you want to deploy it, you need DevOps skills, and you want maybe to run, for example, many people I know are interested in cryptocurrency trading. You might want to run a 24/7 system, maybe distributed over different trading platforms if you run arbitrage strategies. And this is the point where you suddenly need to come up with thousands of lines of code, and this is different code. So once you have mastered here the research and interactive financial analytics side, it only prepares you, let's say, halfway for the DevOps stuff and everything else that comes on the other end, where you on the millisecond level need to take care of quite a bunch of things. And this is where suddenly the deployment gap widens, and you're faced with the last mile problem of algo trading. And many platforms, research platforms out there, I think, are a showcase for that you have, let's say, thousands these days. I think it's close to 200,000 people, for example, doing proper intelligent research on the Quantopian platform. But it's just a pretty small percentage of all these people doing their fantastic research work that really get to the phase where they deploy it. And my hypothesis is that they are also faced with the deployment gap, because it's so hard to get this up and running. And fortunately, this is then where the AI machine comes into play. And in that sense, the AI machine should help you and support you with all the different areas here, starting from the data, going over the features and labels, machine and deep learning, backtesting, and deployment. This is what the AI machine covers. So end-to-end integration, for example, with regard to the historical data that is available, but in particular also the integration with regard to order placement, managing of multiple trades per strategy, and doing a live audit and monitoring. So I don't want to spend too much time here, because this is just the basic message. You will see it in action when I have finished the next few slides, so that you see what is all behind the AI machine in this regard. Here you see a screenshot. It all starts on the AI machine with Python and template-based strategy definition. So for those of you who are Python experts or on their way to become Python experts, basically you feel yourself, I think, back home working within Jupyter Notebook using standard Python code. You can define based on certain templates. Currently, we provide 3 different templates. You can get started easily and quickly with your strategies. And you can then, as a next step, once you have defined it, verify your strategy based on a standardized in-sample and out-of-sample backtesting. So when you use, for example, machine learning-based techniques, you say, well, this is my training period. So here in the example, you see from 1st of August to mid-September. Then you have the testing period, maybe for the last 2 weeks. You get your proper in and out sample testing based on a multitude of available options. It's basically, there are no limits. So we have built the AI machine to be as flexible as possible. And when you say, well, this model from scikit-learn, to name just one package, is not the one that I'm typically using, you can simply replace it in the template definition. So here at this point, where you define everything, you can import what you want to use, and you can adjust all this to your liking and to your requirements. And what I like to say is that the AI machine is not a backtesting platform nor a research environment per se. It's rather the backtesting functionality here is meant to be a confirmatory backtest. So you should have done your research maybe in Jupyter Notebook or in another environment, and now you want to launch your strategy, and you need to model it on the platform in a standardized way. If you use Python, probably the code looks pretty similar to what you have been doing anyways. And here you can then confirm that the results are similar to the results that you have gotten with your backtest. And once you have it then deployed, there are some sanity checks and checks running through. You can deploy it, and the machine takes care of all the signals that are created, of the trades that are taking place, of the signal changes, and does kind of like allow you a real-time audit here with visual view on the current P&L, on the bid and ask price, on the mid price that is used to create the signals, and so forth and so forth. So a standardized deployment of algorithmic trading strategies, and the real-time visual monitoring is then at the core, and you will see it in real time after I've finished this section. To sum it up here, we, with the AI machine, cover the complete algorithmic trading strategy lifecycle instead of single trades only. So when you have a look at, for example, the Onda FX trade application, here you see two positions open, Euro GBP, pound, and the Euro US dollar. You see there are two positions, but basically the application here supports you just with regard to these two positions. The positions that have been before that or that come afterwards, that are actually, yeah, they are just booked. You see them, you find them under activity and so forth. But on a single view, so to say, when here there is an order placed, you see here is a short position, this triangle pointing downwards. This is the only trade that you see. You don't even see the trades before here anymore. But what the AI machine allows you to see here, we have the triangles are not all trades here in that sense. Here are the trades. Here's a take profit that you see. Here is a long position that is entered. There is a stop loss, kind of like an eventful period here for this algo. And these are all signals. So you see all the trades, all the signals, whether the signal has been right or wrong, you see colored and so forth. So the strategy life cycle, this is what the AI machine is about in this regard. But I think this should be enough in terms of having provided a background. Now I can get to the demo. And again, I want to emphasize this point that we are actually assuming with the AI machine that I open here a notebook, that you have done your research in a environment such as Jupyter Notebook. So the AI machine doesn't have the purpose. There are other platforms out there that are pretty powerful in this regard. But you can do, I think, perfectly well your backtesting in an environment such as Jupyter Notebook. I want to quickly walk you through such an example, which is pretty simple enough to be presented, let's say, in 3-4 minutes. And I have then the corresponding implementation on the AI machine as a template. So here I'm working with Onda. I'm using our own wrapper, which is called TPQ-OA. You can install it on your own via pip install and executing this command there. And here I'm doing a few imports. Here, of course, you need to have your own credentials, either for FX Trade Practice. I'm working here with one of our test accounts, which is a real one. Just small money that we trade there typically, but it's for testing purposes. My approach here is or the backtesting is for Euro GBP. 1st of August, 1st of October are start and end, granularity 1 minute. And here, this is something I typically do when I retrieve from an API data, which I might reuse later on or a day later or whatnot. I typically write it as CSV or HDF5 to disk with a certain name, given all the parameters that I've chosen. And when I have asked for this a data set already before, I read it from disk. So it's a matter of milliseconds instead of sometimes seconds, or depending on the data set, it might take minutes until you retrieve it. So here I've retrieved the data from disk. You see we have open, high, low, close. This is for ask prices only. So typically I work with mid prices, but to keep things simple, I'm just relying here on ask prices. for the sake of demonstration. You see here the head. And what I'm working with is simple moving average over 15 bars and with an exponentially weighted moving average, where I set the alpha value to 0.8 here in this regard. And I get kind of my two financial indicators. So this is traditional. Sorry. This is traditional trading based on financial indicators, or studies as they are sometimes called. We have a simple moving average and the EWMA, and we can use these two to come up with our strategy, where we say whenever the SMA is greater than the EWMA, we would like to be long, otherwise short. And I move this by 1 day in order to not fall into a foresight trap. So I'm not here about to explain this in detail, just want to walk you through the major steps. And I'm calculating the lock returns here, doing a drop NA, then I calculate the strategy returns given my positionings, which are +1 or -1 for long and short. And when I now have a look at my tail end of the data set, I see here the returns. When I'm long the market, I earn the market return. When I'm short the market, of course, I earn the opposite. So here, this short position seems to be a good one because the market goes down, and since I'm short, my position goes up. I can visualize the whole approach and you see, well, this works pretty well. But of course, I'm working here based on pretty simplified assumptions. In the sense that I'm not considering bid-ask spreads nor any other form of transaction costs. So this is all simplified. And to show you that this might indeed be a very important factor, you see that there are some 7,773 trades involved. So this might look phenomenal even for the time period, 25% plus, but we need to factor in transaction costs, which I don't do here due to the sake of simplicity and for just having this little example here. So here, your notebook might have, instead of, let's say, 16 cells that I have come up here with in a very simplified manner, but basically going through all the steps for vectorized backtesting based on financial indicators, your notebook might have 150 or 160 cells where you do everything a little bit more thoroughly. But in the end, you have your strategy. And having your strategy means that this, although you do lots of analysis around that, basically here I define my data, my derived data that I use to formulate the trading strategy. So this is then the strategy, and this is the logic, if you like, that needs to be transformed to the AI machine in order for you to deploy it. If there is no AI machine, you would get started writing up a Python script, which might have, I don't know how many hundreds or thousands lines of code. This might even be a little bit different depending on the strategy that you use, sometimes significantly different from one strategy to the other. But you have your logic here, and I stick to this simple example here because the logic is so simple. I think it's for everybody. It's pretty straightforward to see what's going on. Just two parameters here, and we compare these, and we are either long or short in this regard. So having said that, I can now change to the AI machine. Here I need to log in. Going to log in with my credentials, of course. This takes a little bit. You see I have a strategy running here. But before we get to the strategies that are running, and obviously profitably running, which I'm happy about, couldn't foresee that one. Here on the strategy side, we are now having the option to create new strategy. So when I do, for example, new strategy here, I could say, like for example, demo direction, and I would go with direction. You see we have 3 templates, and basically the platform, we can provide, let's say, instead of 330 or 300 templates, but these are basic types of strategies that are currently supported, like directional trading based on machine learning algorithms, technical indicators like the one we had before, or pattern-based ones. I come to these later on. So here, a directional one, I just opened this for illustration purposes. I won't do that much in here. You see that there is a bunch of initializations here taking place, where parameters are getting defined, and then we have methods here in this class, and this class basically now has exactly the name that I've chosen, demo direction. I might increase this even a little bit more. This inherits from TPQ strategy, which is the standard strategy. And I could now get started and add my own things. You see here, there are a couple of standard models that are by default taken care of and that are imported, and also some SMA-based indicators are by default made available, but it's not too long. You see here, I'm already at the end. So this is Jupyter Notebook, this is Python, and you could now get started with changing this template. So I don't want to work in this template, just to show you how I would set up a new one. I have prepared one. You see here now upload. I would need to upload it in order to make use of it. But I have here prepared one that is called, like cryptic name, SEWMA. So for simple exponentially weighted moving average, this is the combination of my strategy backtesting. You recall, here is the logic. I have SMA and exponentially weighted moving average. And when I open this, here I haven't saved the changes before. This is why I got prompted there. So I need to save a checkpoint. So and now I'm in my SEWMA tech, so for technical strategy, and this is something I've prepared before. And maybe you see here, going through the parameters, euro yes dollar is what is defined here by default. Maybe I want to change this to GBP, for example. By default, the frequency 1 minute, that should be fine. This is what I backtested. Half-life, I haven't done any half-life, so I'm going to change this now. What I have used is the alpha parameter, and I might change this to alpha instead of half-life, but I might need to change the code down there as well. So you see here, I'm now doing changes on the Python level. Later on, you will see how this changes the forms. So here, there is some stuff that's not needed anymore. So I can now adjust this. I can delete, I can add, I can work. And here I might, instead of half-life, I might say alpha, and define alpha instead of the half-life. We have a few options there for the exponentially weighted moving window. And here you see this is my SMA that I define as before. There is the EWMA. This is also defined as before. Of course, we have now, let's say, our class-based syntax, and we have a couple of standard naming conventions here working with close. We need to add a close behind that, but these are kind of simple rules. And when you know a little bit of Python, I think this should all come quite natural in a Pythonic way. So I have now done my changes. Let's say this is what I wanted to change, and I would need to save it now here. And I now finished here on the level of the template. So I have started with something, I've done my changes. I could have started from scratch and have then done the stuff in the same way, But to speed things up, I've started with what I've got. And when I close this, you now see that an upload link appears here. I need to upload this now. There are some sanity checks that are done, for example, with regard to syntax and so forth. But not every, let's say, a logical error or mistake that you might make is captured. So we hope at this point where we have uploaded that there was, we see that there was no technical issue that was immediately detected, so that we can now move on towards the next step and do the backtesting. So here, backtested models, you see there are quite a bunch of backtests here. And before I show you maybe some other backtests that I've done before, I add now here a new backtest model. Here I have the selection, and I can select from all available ones. We have a few standard ones and the template-based ones. Working here with the Euro GBP, frequency every minute, the interval. And I think for the backtesting, I have chosen alpha. Here we see alpha was chosen to be 0.8. So I might go in line with what I've done during backtesting. And the testing is here 1st of August going to 1st. This should be the same thing. So what you saw before I changed this to EWMA alpha, this was half-life. And here in the form that is used, that you see to set up a backtest, this is all changed. So what you change on, so template-wise, on the Python level is reflected here dynamically in the application later on. So I get started with that one. And in the meantime, you see here it's saying in progress. It's running, and I might have a look, for example, at that one here, 5 minutes. When I open it, you see here, we just have for the technical indicators, we just have in sample or out of sample. So it's not kind of like differentiated really, because there is no training taking place. And you see here the performance, the in sample performance of the backtest that I've created before. But this is based on 5-minute data, same time interval. This was when I have defined it based on half-life, not on alpha. So I can go, for example, to that one. It's another one that I did today. This isn't going longer, but it has much more data because I can go to 1 month, for example. I can also zoom in a little bit more if you say, well, I want to see this a little bit more detailed way here. But of course, when I work with 1 minute bar data, I have 5 times as much data as compared to my 5-minute bar case. So here, this strategy that I've now backtested, when I click on it, it's loading the data and it looks kind of nice. We see here we end up with some end performance of 1.26 is what we get for the model returns. Again, this is also here not including yet, I must say. We can, of course, change many things in the near future. This is not yet including transaction costs, so it's also a simplified way. And here, when I go down here and have a look, you see, yeah, we are also ending here at some 1.25 or 26. So it's roughly the same thing. It's a different scaling here, of course. So, but it's roughly the same thing. So this is what I mean by a confirmatory backtest. I have done it here in Jupyter Notebook. I have put in hours and hours of work. I'm pretty sure that the results that I see are the correct ones. But when I need to translate it then on the AI machine to my strategy, to that one here, where I have my template-based approach, I should then check whether the results with the same parameters are basically the same. And we see here we end up roughly with the same numbers. I could check this for every minute detail, but I think you get the message here. So now we say, oh, well, this looks fantastic. And for the minute, let's forget about the transaction cost that we simply have defined away for simplification purposes. And then you would say, oh, this fantastic thing that I have discovered, I'm going to get started trading. So you see here in live models, here this is currently is toggled, and I can show you later on why it is toggled. This is now running on Euro US dollar, and this is a limit that we currently have, that we can per instrument. Here in the backend, it is Wonder that is running. That per instrument, we can only run one strategy. So when I now want to run a second strategy, it should be on a different instrument. And here I'm doing it on Euro GBP, and I go live. And the quantity to trade, I usually do it with pretty small amounts. So when I trade like 200 and I have a leverage of 20, this is just 10 euro that I risk. The percentage is in terms of the price. Since I have a leverage of 20, I would set here for 2%. I would set it to 0.1. So 0.1 times 20 gives me 2% for the stop loss distance. This is trailing stop loss. And take profit, I typically set to 4%. So 0.2 times 20 gives me 4%. And why do I trade 200? Yeah, with a leverage of 20, I get 10, and it's easy for me to then calculate just by visual inspection the relative performance of the algorithm. So now when I say add model, and this is the one where I have defined the template for, where I have done the backtest, and from the backtest I now start the model here, and it says now, well, it has started. So let's have a look whether it has started indeed. And indeed, we see here a running model, and immediately for these, this is typical for the technical ones, it has opened a position of 200. It has gone long here in the position, but this one is currently toggled because obviously a stop loss has been triggered, a trailing stop loss. So the strategy overall is still 0.72. So this is running for 2,000 per trade, which means it has done plus 0.7% over the period it has been trading. So when I click on that, we should have a rather lengthy history here for like when I go to 30 minutes or 1 hour. You now see what is happening during 1 hour. And there was a stop loss triggered. You see it towards the very end here. And the stop loss was not kind of like at my minus 10%, it was a trading stop loss. So because I have had probably some 2% plus, the position was closed out at close to zero. There is a long position that the algo has entered. There is the short position the algo has entered, a long position. And you see every single signal here. You see the ask and bid prices, you see the triangles, and here you see a wrong downtick prediction. This is a pattern-based trading strategy which predicts levels. It's not about going up or down, it's just indirectly about up and down. It predicts certain levels, like here a current level is 16, and it predicts maybe a level of 15 or 13, and accordingly it changes position. So here you see a wrong downtick prediction, current level 15, and it predicts a level of 14. So in that sense, you would like to be short, but it was wrong. And at this point, it suddenly says, well, we have a current level of 14, but it predicts 16. So an upwards movement, and you see then suddenly this all goes fine. And here it perfectly matched the turning point. Where it now says a short position should be entered because it predicts a lower level, and it enters a short position. So this has been started earlier in the day. So when you have a look at it here, we have 2 p.m. currently here on the machine. This is GMT. And on my system clock, you see 4 p.m. So 2 hours plus GMT, 2 hours. So we need to keep this in mind. This is GMT time, so meaning we have the standardized time here shown, not my local PC time. This is running in the cloud on a kind of not really large cloud instance, but kind of like a powerful one. So we have this one strategy running, but I want to this because this is by incident it is toggled meaning it now waits until it re-enters the position. I can close this. The other one is running now. And there we should see some live action. This is, there we don't have that much yet. So when I go back, it starts here with a long position. And here, see, this is a correct uptick prediction, a wrong one, and a right one. So you see, as it's as we are watching here, it is moving. We retrieve data in real time, and bid-ask spread, the mid price, and also the P&L here is updated accordingly. I can also have a look here at the P&L sample and see it slightly using there. So real-time update, and it's running. And basically, I'm showing you two strategies, and you see here we can have multiple strategies running, but again, per account, we are limited due to the very architecture that we face to one strategy per instrument as of now. When I now quickly open FX trade, I can also show you the positions in real time. So I'm now logging into the desktop application of Wanda, which is called FX Trade. It takes a little while until it retrieves the data, and we see at this point in time we have one open position, and the open position is related to Euro GBP. It's 200 units, and here I'm showing Euro US dollar. Now I can show you here the Euro GBP one. There's a long position. It's losing a little bit of money, so this was a wrong prediction, obviously. Here the first one when it entered it, and on the other hand, we have this one strategy running here in live as well. When you compare the unrealized P&L to the one that you see here, they roughly coincide, but there are different, let's say, rhythms via which the data is retrieved. So the app, for example, gets data updated also in real time, of course, but sometimes with slightly different rhythms than what we get via the API. And of course, we have a little bit of processing, but you see here unrealized P&L is minus 0.5 and minus 8. Sometimes here we are leading, sometimes there, but roughly this coincides. So when it goes up and down, and of course we can have a look at the running strategy here as well. So this again is a simple strategy in the sense that we are working with traditional indicators, simple moving average, exponentially weighted moving average. You can come up with any indicator that you fancy. We are planning to add more indicators in standardized fashion as we go. And this strategy here that has been running for a few hours, the other one, now it's showing me the pattern one. Here I need to zoom out a little bit. This has been running for hours. This is a machine learning based one where we have trained a support vector machine algorithm, which is based here on 5-minute frequency. So it doesn't create new signals that often. But you see alone here, when I go over this interval, we have seen quite a bit of action. There's a short position, there's a stop loss, there's a short position, a long position, short position, long position. So quite a bit of trading has been taking place. And once again, of course, we see all the single trades reflected in the FX Trade app. But what the FX Trade app doesn't really support you with is kind of like the history of the single trades. It simply doesn't know that this trade belongs to that trade and to some others in that sense. But what we can do, and I want to show you as one of the final elements here, is from a live audit, or when I close this and I show, for example, all strategies that we have been running previously, I can have here, for example, FX pattern. Let me take that one. I get the historical audit there. I have here in tabular form all the audit information that is currently recorded. We will add on that as we go as well. So this is currently just what we have, and we can export this as CSV file, and I can download this. I have done this already, but you can, from the platform, download all the information that is of importance related to a strategy run, let's say from in the morning 10 to afternoon 4. And you can use standard analysis capabilities like Jupyter Notebook, with which we have done the backtesting, also for analysis. So in that sense, here I'm having a pretty simple, I just do standard stuff here, pretty standard Jupyter Notebook, where I import just the basic things like NumPy and pandas. I read the audit details here for something that I've been running this morning. So it's my example here. I have run this morning. I read in this with pandas. I have the raw data now from the machine available here. Again, we are going to add more information to all this. This is completely flexible, but currently we have been focusing on the live monitoring. And I can process this, and for example here I pick out the positionings that I have. I calculate the differences in trade price, the position size, and once I'm finished with that, I have this is now a quick run through. You see the results here. I have the position where you see the price difference and the P&L given the position size. So I can, via a few lines of Python code, once you have done this, you can repeat it. We will also provide standard templates in order to accomplish that. You can calculate for this strategy I've made, or the strategy have made, I was the initiator, but the strategy itself had made a loss of 2.42. Given that I have had equity of 100, this means that minus 2.4%. Or I can, for example, also plot my P&L over time. When from the time I started it, this was around 8:50 our time, 6:50 GMT. It was running for like 2 hours for testing purposes, and this is the point where I stopped it out, and we see how the P&L evolved over time. Again, this can be arbitrarily enhanced, and we can add any kind of statistics here, but this is to show that once you are finished with your strategy, you have just this one click where you can export the information to a CSV file. And as seasoned Pythonistas, you know, of course, how to process the data. So here one strategy is currently profitable, the other one has realized a small loss. And with that having said, I want to finish up the demonstration and the online session here with a quick summary of what the AI machine is about. Still, it is, of course, work in progress, but you have seen that many of the cornerstones of the major pillars that we had in mind from the outset are there already, are working and are scalable, are running robustly. We have run strategies for like whole week, day and night. This all works. And the major benefits, I guess, for, let's say, the typical retail algo trader who knows Python, who knows research, who has ideas for strategies, but who doesn't have time nor maybe skill or nerve to write thousands of lines of code to deploy it and to monitor it on his or her own all day. We have the end-to-end integration with trading platforms, currently with Wonder, from historical data to tick event streams to trading. You have a template-based environment where you are basically fully flexible with regard to what algorithmic trading strategies you want to define. Of course, you're currently somehow limited to the data, but within the realm of the data available from Wonder, from later on FXCM and so forth, you can define your strategies for backtesting as well as for live trading. And the models are exactly the same. So we have the same model description based on the template for backtesting as well as for live trading. You know what is deployed. There is no kind of like natural break in the chain, in the process chain there included. Live monitoring and audit for multiple strategies. You have seen interactive visualization of all events, signals, the performance, etc. and you're able to manage the strategy lifecycle. So you have full transparency from start to finish. You can do your post-trading analytics by a simple export based on standard Python functionality and standard Jupyter notebooks. So when it gets to the standardized deployment of AI-based trading strategies, and you are a Python fan, I think the AI machine is the right way to go. We currently don't have yet test versions, demo accounts available. This is something that we are working on. So expect a little bit more in this regard to come soon. But this online session here was meant to give an update about the status quo, what this project is about. And since we are working full force on the AI machine side, expect more fantastic things to come. You might notice that I'm pretty amazed and excited for what we're doing here, because this is something I always imagined to have at my fingertips, not to sell it to somebody else, but to make use of it for our own. So this was the major or the primary purpose, and of course we are building it for others as well. So when it gets to the others, and you might be one of the others, then bear a little bit longer with us, and soon I guess you will be able to benefit from the AI machine as well. This leads me to the close of today's session, and I wish you happy Python coding, happy algorithmic trading, and also in the future happy algorithmic trading strategy deployment, because I think this is still something that our industry can do a better job, and we try our best to make this as seamless and as straightforward as possible in this regard. Maybe there's just one question here that somebody's saying, what about the proprietary strategy, about your IP, so to say? We haven't technically nor legally decided that, because currently we are just working on the machine, on the AI machine, for ourselves and doing testing, development, deployment for our own stuff. But of course, this is a very important factor that people need to be able or need to be sure that what they put on something like the AI machine is their own IP. So if you are the inventor of something, by definition, I think this is, so to say, a global definition, you have the copyright for all this, but of course there will be technical means in place once multiple people are there. There are many different technical routes to make sure that the IP is protected, but again, this is under discussion. We have some good ideas in this regard, but they are not yet implemented, because once again, we are still in this development phase, let's say just before large milestone that we had with the plans for the AI machine. And once we get to the point where we open it up, these are topics, of course, that get addressed in a serious and proper manner. If you have more questions, feel free to email us. ai@tpq.io or team@tpq.io are the best venues in this regard. Having said that, again, all the best. Use Python. All the success with algorithmic trading, and expect more from the AI machine and from our end soon. Take care. Bye-bye. See you.